Good morning, Tehmina Khan is here in TKMaths S1. In today's video, which is video number 2 on momentum, we will continue to study the basic of momentum. We have seen in first video what is momentum and simple application. Now we will move on to the principle of conservation of momentum, right? So here are 3 QR codes. To watch more videos on P3, S2 and M1, you can scan these QR codes, right? So now we are seeing what is law of conservation of momentum. So when two bodies are traveling, for example here, now there are different condition, different direction in which these bodies are moving. Right now, just for an example, I have taken that both the bodies are moving in the right hand side direction as the arrow is showing. And after the collision, the body are continuously moving on the right hand side. There are different situations when bodies may move in the opposite direction. One of them may stop. So anything can happen. So we will see all those cases. But right now, important thing to understand is that when impact happen, when two bodies collide, there is a transfer of momentum between them. Either the momentum will move from first body to the second body or from the second body to the first body. But important thing here is that before and after, the momentum of the system will remain same. So what do I mean by that? We know momentum is mass into velocity, right? We have seen last time in the last video. So for this body, the momentum is m1 time u1. u1 we are taking for the initial velocity before the impact. And m2 u2 is for the second body because there are two bodies. Now when collision happen, this is called now final velocity is v1 and v2. These are general terms, right? So momentum of both the bodies before collision is equal to the momentum after the collision. So this law is called principle of conservation of linear momentum, right? So let's see this application in the question. So rule of law of conservation of momentum is total momentum before collision is equals to total momentum after collision. Now what happened after collision? There are multiple situations. We will see different situation in different questions. So let's see this one. Whenever you have a question on momentum, I would recommend that you change it into mathematical form and draw the diagram. For example, I have done here for before. Two bodies are moving directly toward each other. So you can see the arrows I have drawn here, right? They are moving toward each other. Ball A has mass 3 kg, which I have mentioned here, and is moving with the speed 5 meters per second. I have written here. And ball B has mass 2 kg, it's written here, and is moving with the speed 2 meters per second. Why did I write -2 here? Because it is in the opposite direction. So when we are talking about velocity, it means we have to mention the direction. Otherwise, magnitude is speed, which is written in the question 2 meters per second. But because they are moving directly toward each other, it means the directions are opposite to each other. So one of them has to be negative. So conventionally on the number line, we consider the right hand side as a plus and left hand side moving as a negative because it is getting smaller. So it is just that convention. So we have drawn the diagram here. Now what happened after collision? See here. After the collision, ball A continues to move in its original direction. So this was the direction of ball A. So it is still moving in the same direction, but at the reduced speed of 1 meter per second. Mass of course remains same. Velocity we have to see. So it is now 1 meter per second. You have to find ball B is moving after the collision. So velocity of ball B you have to find out. So this velocity you have to find out. Okay. V meter per second. So now according to the law of conservation of momentum, I will write down the momentum before. So it will be ball A will be what? Mass into velocity plus this mass into this velocity. This is before collision, right? You can see here. I'm writing here MAUA plus MBUB, just symbol. Okay. And then I will substitute the values here. You can see here 3 into 5 because velocity of ball A was 5 meter per second and mass was 3. So I have just substituted here. And 2 times minus 2. Similarly, for after the collision, it is MAVA. Diagram always helps you to fill it very quickly and easily without making any error. So this is what we have to find out. So now it is a simple straightforward question. You will simply calculate it and find out VB. Now the question said, if you have read it carefully, find how ball B is moving. It's not only about its magnitude, but how it is moving, mean in which direction. So when your velocity is 4 plus 4, what does this show? That it is moving to the right side. Earlier, what was the direction of B? Earlier, the direction of B was here. I should not have drawn arrow here because I don't know until I get the answer. If it is negative, it is going in that direction. So now the value of ball B tells us that B moves away from the collision at 4 meter per second. Since it is positive, it moves to the right. So this is how you will interpret the what is the value V is 4 is representing, right? So this is how you will interpret it. Let's see another example. And if you want to put the video on pause and want to try out this question yourself, it would be wonderful. So again, after reading the question, I will draw the diagram here because it always makes life very easy in momentum. Two ball bearings are moving directly toward one another. So again, arrow are facing each other. The first ball, I have given the name first and second inside the circle. The first ball has mass 20 gram. Now we know the unit of momentum is kilogram meter per second. So if it is given in gram, you will change it into kilogram. That's why I've written here 0.020. And it is moving with the speed of 3 meter per second. So I have written here. The second ball has mass 25 gram, which is 0.025 kilogram, as mentioned here. And it is moving with the speed of 1 meter per second. After the collision, the first ball bearing is stationary. So this will come to stationary, okay? So let's see here. Okay, so now for first ball, I have written the velocity 0 here. Mass will remain same. What is the speed of the second ball bearing? That we don't know, so we are writing it here. That we don't know, so just V. So now according to the law of conservation of momentum, before collision, finding the momentum of both the objects, first ball and second ball, and this is how you will write it down. Simply substitute the values here. Achha, by the way, I have written here 1. It should be minus 1, right? Because it is in the opposite direction. Similarly here, you will substitute the values here also. Okay. So now solve it. And what is your V coming? 1.4 meter per second. So it means it is moving to the right hand side direction. It also changes the direction from its initial state. So thank you very much for watching this video. In next video, I will take more question with respect to coalesce when bodies after the impact combine together, right? Those type of questions. So please press like and subscribe button and you will get the indication of the next video immediately. Take care. Allah Hafiz.